Hello, it's Mr. Eason again with some review help. Today we are going to be reviewing double-digit multiplication, which means 2 digits times 2 digits. In 5th grade you guys will be doing 3 digits times 2 digits using the standard algorithm or the old school way. All we need to know how to do is the 2 digit times 2 digit, and we can use any strategy we want. So I'm going to be showing you a couple of those. Before we get into the full double digit times double digit, I'm going to make sure that you understand a really important skill that you need to be able to do before we can do double digit times double digit multiplication. And that is understanding how to work with multiples of 10. So, for example, if we had something like 26 times 10, we wouldn't have to set up a big, huge equation for that, because anything times 10 is itself with a 0 on the end. Because basically you can pretend that that 0 just isn't there, and it's 26 times 1, and that's 26. But since we scratched out a 0 here, we need to put a 0 on the end, and that's 260. That's a really easy way to do anything times 10, but some people just don't ever remember that. It also works with multiples of 10. So if we were doing 26 times 30, we would really be doing 26 times 3. So we could just solve up 26 times 3 here. That would be 18, 78, and we would have 78, and since we scratched a 0 out, we put a 0 on the end, and it's 780. So that's a pretty simple strategy, simple thing to remember, and it's important because a couple of the strategies that we're going to be doing today involve using this trick. The other thing I'm going to remind you about is if you have two numbers with a 0 on them, maybe you have something like 30 times 40, you can scratch out both zeros, and you can do 3 times 4, which is 12, and you put the 2 zeros back on the end that you scratched out, 1200. Pretty simple. The only time that people sometimes get messed up is if you're doing a number that gets a 0 as an answer, maybe 50 times 4. Well, you scratch out your 0, and 5 times 4 is 20. Sometimes people see that 0 and they don't think they need to put it back on the end. You have to add it back onto the end, because if you don't, it's not obviously correct, because 20 is less than 50, and you're doing 4 50s. So, it would be 200. So if we can remember that strategy, that skill, then we're going to be fine for our double-digit multiplication, because everything else is pretty much just knowing your multiplication facts. So we're going to go ahead and move on here. I'm going to show you two different strategies. One strategy is the area method. It involves drawing a box and splitting it up and doing some multiplication. The other strategy is breaking apart one number. I tend to like that strategy better because it is a little quicker, but any way you choose to do it is fine. And then after I show you a couple of each of these strategies, I'm going to show you how they connect to the standard algorithm, which is the old school way, which is the way that your parents learned it, I learned it, and you will be learning it in 5th grade. So, let's go ahead and get started. I'm going to pick an equation, maybe something like 52 times 34. Let's try that 4 again here. 52 times 34. So, the area model tells us that if we're trying to find the area of this rectangle, you just multiply each side times itself. Well, you can split that rectangle up into easier to work with pieces. So I'm going to split it here, and I'm going to break apart each of these numbers so that they're easier to work with. So we're going to label the top and bottom, 50 on the big side and 2 on the small side. You don't have to label top and bottom, but sometimes it's easier just to help us remember the strategy. So the sides, we're going to label 30 and 4. All we're doing is we're breaking those numbers apart by place value, just like we did when we were doing our break apart strategy for single digit multiplication. So, all we have to do now is we need to find the area of these smaller boxes. And the top left box would be 30 times 50. And again, 3 times 5 is 15. 2 zeros in it is 1500. The top right box is 30 times 2, which is 3 times 2, 6, with 1 0 on the end. Bottom left box is 50 times 4, which is 5 times 4, 20. Hey, we just did this equation. Put your 0 on the end, 200. And the last box is 2 times 4, and that is just 8. There is no zeros on the end of that, so we don't have to put anything on the end. So the last step here would be to add all those things up. I don't have room to write an equation, but if we did 1500 plus 200 plus 60 plus 8, looks like we're going to get 1768. So the answer to that equation would be 1768. Pretty simple. So now we're going to do the break apart strategy. We're just going to break apart one number. It doesn't matter which number you pick. We're going to do the same equation. And I am going to do 52 times 30. And I'm going to do 52 times 4. So I broke that 34 up into 30 and 4. And now we can go back to that zero strategy. 52 times 30 is the same as 52 times 3. I do 2 times 3, which is 6. I do 5 times 3, which is 15. I put a 0 on the end of it. It's 1560. Now I do 52 times 4. 2 times 4 is 8. 5 times 4 is 20. And now the last step is I add up my 208 and my 1560. And when I add that, I should get the exact same thing I got on the other side. So that's an 8, 6, 7, 1. 1768. So there's a little bit less work to do on the breaking apart one number side, but if we're not really sure how that works, the area model might be a better way for us. Okay, there are definitely pros and cons to each strategy, so you just have to pick the one that works best for you. We're going to do one more with both of those, and then I'm going to show you how to connect it. So we're going to try another double-digit equation. Let's do something a bit more challenging this time. Let's try something like 78 times 94. So when we do 78 times 94, again, we need to split our box up and label it. So we'll do 90 and 4 on the top and bottom. And I could do 90 and 4 on the sides. It really doesn't matter where I do it, as long as I split them up correctly. So we'll do 90 and 4 on the top and bottom. We'll do 70 and 8 on the sides. And so now all we need to do is we need to solve the equations. The top left box, it has 90 and 70 beside it, so we multiply 90 times 70. 9 times 7 is 63, so we put 2 zeros on the end of that. On the other side, we have 70 times 4, which is 7 times 4, 28. Put a 0 onto that. 8 times 90, that is 8 times 9 is 72, with another 0. And 4 times 8 is 32, no zeros to put on. So we just need to add that up. I definitely will need to add this one because I don't think I can do it in my head. So we'll just put it over here for right now and I'll erase it next. 6,300, 280, 720, and 32. Add that up. Let's see, 8, 2 is 10, plus 3 more is 13. 7, 3 is 10, plus 2 and 1 is 13 again. 7,332 should be our answer here. So, now we will try the break apart strategy. Let me erase all this addition over here. So the break apart strategy will be breaking apart one number. Again, there will be a little bit less writing, but a little bit more, if not as concrete. You don't get to see a picture of why this is happening. So we'll break apart the big number this time. So we'll do 78 times 90. And we'll do 78 times 4. 8, and remember we scratch that 0 out. 8 times 9 is 72. 7 times 9 is 63, plus 7 more is 70. Then we will do our next, we need to put our 0 on the end. Oops. Next we'll do 78 times 4. 8 times 4 is 32. 7 times 4 is 28, plus 3 more is 31. And if we did our math correct, we should be able to add that up. And already it looks like it's going to work. If we add our 7,020 on the end, we get 7,332. So that does end up working, which is very, very handy for us. A little bit less work, and what we're going to do now is I'm going to try to connect this break apart one number to the standard algorithm or old school way, just so you can kind of understand how it's working, because there are lots and lots of connections. One last equation we will solve, and we'll do the break apart one, and then we will do the standard algorithm. So let's do something a little bit simpler now. Let's do 28 times 15. Alright, so breaking apart one number, we could do 28 times 10 and 28 times 5. So we will do 28 times 10 is pretty simple. It's just 28 with a 0 on the end. 8 times 5 is 40. 2 times 5 is 10, plus 1 more is 14. So we have 140 plus 280. That should be 420. Alright, so now we're going to do the standard algorithm here, which is the way that we learned it probably in school if you are a parent watching. So 28 times 15. And we learned that we do 28 times 5 here, so we do 8 times 5, which is 40. We do 2 times 5, which is 10, plus 4 more is 14. Then we drop a 0 down, or we move over a place. It could be either way. And then you do 8 times 1, which is 8, and 2 times 1, which is 2. Then you add the 2 up, and 0, we've got 420. Same thing. So let's make these connections here. We've got our 140 down here, which is the 28 times 5. And we have 140 here when we did 28 times 5. When we put that 0 down here, it's just like breaking it up into 10, because that 1 is in the tens place, which is why we put that 0 there. Then we do our 28 times 1 here, and then we get 280. Same thing as doing 28 times 10 down here. So essentially, when we're doing the break apart strategy, it's the exact same thing as the standard algorithm, just kind of split up into two different equations. There's really not much more work for to do the break apart one number. We're just kind of showing them how to do it so that when they get to the 5th grade and they have to do that standard algorithm, it won't be so foreign. They'll kind of understand, oh, well, that's why I'm doing this. So this has been kind of a long video, but double digit times double digit multiplication is an important skill for us to remember. It's going to be coming back lots, not just in 5th grade, but throughout the rest of your math in school. So with that being said, this is Mr. Easton with review help for double digit multiplication. Thanks. I'll see you next time.